Good day. Here comes your Unit 3.2 lesson. So it's about the law of conservation of energy, which you've heard about in the past few years. If I may recap 3.1, since it's linked to this, we talked about heat, which is the energy exchange between two bodies of different temperature. And we talked about temperature, which is the amount of kinetic energy within one substance in particular. So obviously, the more kinetic energy, the more movement there is, the higher the temperature. And when there's a temperature difference between two bodies, two substances, then there will be a transfer of heat from the hot one to the cold one. Now, during that transfer, there's no energy that's really lost, there's none that's created, it's just being solely transferred or sometimes transformed. We saw that in secondary 3, transformations of energy. So for example, when you hear the bell at school, well, it's electricity that's powering the bell, and that electricity is being transformed into sound energy, which you then hear in the form of the bell ringing. So that's a transformation. But a transfer is really when something goes from hot to cold. So it's only thermal energy that's going from A to B, from hot to cold. So energy is transformed or transferred, but we don't create any, we don't destroy any. Sometimes we'll say that some energy will end up in the environment. It's not that we're losing it, it's just really that it's being, again, transferred to the environment. So a system may lose some energy, but it's not really that it's being destroyed, it's just that it's being transferred to the environment. Therefore, there's less left in the system that we are studying. So speaking of system, a system in our case will be a location that's being observed. Most often a beaker, an Erlenmeyer flask, or something like that. It can be opened, closed, or isolated. So if we look at the three beakers here, I'm going to go through a little exercise with you. So in this case here, I have an insulator around the beaker. So even if there's a hot solution in here, the heat can't escape the beaker. So there's no heat exchange with the environment. It's perfectly insulated. So the question is this an opened, closed, or isolated system? Well, obviously, since there is an insulator around it, it must mean that it is insulated. Very good. Now, if we look at this one, there's a lid on top. So that means that whatever liquid there is in here, let's say it's water, it cannot escape. So whatever vapor is being produced will stay within the system. It can't evaporate into the environment. But the heat from, or the energy from the beaker, let's pretend this solution or this liquid, whatever it is warm, that heat will be able to go into the environment through the walls of the beaker. So now in this case, is it opened, is it closed, or is it isolated? If you said closed, you're correct. Let's put it here. So it's closed because of the lid. The matter itself can't go anywhere, but the energy can leave the system through the walls of the beaker because these are not insulated. So again, when we talked about open, closed, or isolated, we're looking at these energy-wise. Can energy enter or leave the system? If the answer is yes, then it's either opened or closed. So in this case, it's closed because of the lid. But if it cannot enter or leave the system, then that means it's insulated. So in this case, I have an open beaker. Matter can leave, energy can leave, or it could enter as well. So in this case, I have an opened system. Okay? There you go. First slide number 1. Slide number 2. In chemistry, when we want to study the amount of energy involved in a reaction, we'll use calorimetry, and we will use what we call here a calorimeter. So first of all, calorimetry, it's experimental determination of the amount of heat involved in a transformation. So we are measuring how much heat, how much energy is involved in a transformation. It could be an absorption, could be a release of heat. And that could be for a physical or a chemical reaction, regardless. So we're going to get into the process during another lesson, but for now I just want to show you the apparatus that we use to perform those experimentations and therefore measure the amount of heat involved in those transformations. So this is called a calorimeter. So you have a lid on top because we don't want to gain or lose any matter, nor energy, mind you, but this is mostly, well, no, actually it's for both. Let me not talk through my hat. So the lid is there to stop matter and energy from entering or leaving. I have a stirring stick because we all know that if we stir a solution, it will speed up the reaction. I have a thermometer because I need to measure the temperature of the environment in which the reaction is occurring. And I have here a whole insulation system, so to speak. There's air, so it's like a double cup. I have a cup or a container within a container. And the insulator in between is air, a little bit like people in the Middle East will wear many layers of very light clothing, and the air that's caught in between, that's trapped in between the layers, will actually keep them cool, as crazy as this may sound. So air can act as an insulator. You have the same thing in windows at home. Between the two panes of your windows, the air acts as an insulator. Okay, so I have the inner vessel, the outer vessel. I have air that acts as an insulator in between. So energy cannot leave and energy cannot enter the system. So whatever is happening in here stays in here. And we can measure the difference of temperature from the beginning to the end, between the very beginning of the reaction and the very end of the reaction, to see how much energy was involved and was that energy absorbed or released by whatever reaction happened in this environment. Okay, so that's it for 3.2. All you needed to know was what is calorimetry, what is a calorimeter, and back here, what kind of systems are we going to be working with? So either an open one, a closed one, or an isolated one, and what difference does it make with the amount of energy that can enter or leave the system. So if you understand all those concepts, you're ready to go and practice by answering questions in your textbook. See you next time for 3.3.